All right, time to put the alternating series test to the test. Okay, so we want to test each one for convergence or divergence. So this first series, you might recognize that this is very closely tethered to the harmonic series. We call this alternating harmonic series. So if we define this as, from 1 to infinity, -1 to the n, -1, bn, then bn is just the harmonic sequence. Okay, so then we just need to go through and verify our three conditions. That condition 0 is bn positive. Yes. Okay. So, and that's for all n. Yep, that works. Okay. Is it decreasing? Okay. Well, again, you can do this in various ways. You can look at it as a function and say, well, the function is has, derivative that's always negative. So, yep, it's going to be decreasing. You could also do it formally with algebra, but moral of the story is it is decreasing. Then the last condition that we need is the limit of bn as n goes to infinity 0? Well, yeah. Okay. So then, really, you can say by the alternating series test, I'm abbreviating, series n is equal to 1 to infinity, -1 to the n minus 1 over n converges. Okay. So, one example under our belt. Now, notice that if you review the alternating series test, it doesn't say anything about divergence. So if we have an alternating series that we believe diverges, how do we go about doing that? Well, I'm glad you asked, because this next one is going to be divergent. Okay, so let's just kind of go through as we would, right? So I'm going to be lazy and just say that this whole thing is bn. Is bn positive? And for all n, yeah, it's going to be positive. Okay. Is bn decreasing? Well, again, you can, do one of the other methods, and please verify that on your own. So you look at it as a function, take its derivative, or prove it directly using algebra. So that is to say that bn is less than bn minus 1, okay, but this does end up being satisfied. Now, the trick comes in looking at the limit. So the limit of bn, what is that? I think that is, so this 1 really doesn't do anything. The limit is going to be 1/2, which is not 0, right? So that fails alternating series test, but at the same time, remember we had that nth term test, and we said that the if the limit of the sequence was not 0, then it diverged. So to conclude divergence, we can just use the nth term test. So I would say by nth term test series n is equal to 1 to infinity, -1 to the n, root n over 1 plus 2 root n is divergent. Okay, so that's an example of that, and for this last one here, I want you to do the work. Okay, so go through and either prove convergence or divergence, and resume the video when you're ready. So here's what I have so far. Bn is positive, Bn decreasing. And so I started doing, instead of the derivative route, I did more of the direct definition. And now here, I run into a fundamental flaw. I say that 1 is less than this, but this, right, this inside here is going to be a number that's less than 1. And so when I take a power of it, it's not going to be decreasing. So this one isn't going to be satisfied, which then leads us to think, okay, we can't use convergence, or we can't use AST to prove that it's convergent. So maybe then we can look at the limit of bn, and I'm going to tell you that's going to be your key here, but you're going to get that it's going to end up being divergent. Okay, we'll actually be able to do this more formally with the tests coming up.